Okay, this is part two of the solution to the problem. Here's the problem stated here. In the figure below, the triangle is inscribed inside the circle, center 0, radius 10 centimeters. Find the lengths xy so that the area of the blue shaded region, which is here and then a little bit over here, here and then a little bit over here, the area of the blue shaded region is twice the area of the triangle. Now, what have we done so far with this problem? First, we notice that the area of the blue shaded region is going to be the area of this semicircle minus the area of the triangle. We know that. We also know that any triangle inscribed in a semicircle is a right triangle. We know how to compute the area of this triangle, 1/2 base times height. We know how to compute the area of the semicircle. It's pi r squared divided by 2, where 10 is equal to r. So we work with that, and we have gotten to this point. We have gotten to this equation right here. The equation is x to the fourth. X is one of the dimensions on the triangle, plus 100 pi divided by 3 squared is equal to 400x squared. Now we want to solve this equation. Let me take this term right in here and bring it over to the other side of the equation so that my equation now looks like x to the fourth, okay, minus 400x squared plus 100 pi divided by 3 squared equal to 0. Okay, so now I want to solve this equation. I want to find the values of x that make this whole thing on the left equal 0. Wow, well, I know you're just doing algebra 1 here, and solving a fourth order polynomial equation is probably not within your domain of skills at the present time. However, we can use a little trick here to solve that equation. And it goes something like this. And that if, for example, if we say, hey, let's let z equal x squared. So everywhere where there's an x squared, I replace it by z in this equation. Well, x to the fourth is just z squared. So I have z squared minus 400x squared. 400x squared is just 400z. And then plus, I have 100 over pi, 100 times pi divided by 3 squared equals 0. Now this is not a fourth order polynomial anymore. It is a second order polynomial. And I know that actually at this point in time, you are studying how to solve equations like this in algebra. So you can solve this by completing the square. You can solve it using the quadratic formula. There are several ways to solve this equation for the values of z that make this expression equal to 0. Okay, now I've solved the equation, and I won't go into all the specifics how I do it. I solved it by completing the square. And what I found were that the solutions to the equation where we x can take, well, let me show you, I plotted this equation on my graphing calculator. Let me show you what that looks like. So here's a plot of the equation on the graphing calculator. Notice, by the way, the scale on the y-axis, this is plus 8,000, this is negative 8,000. I mean, this is this scale goes to large numbers very quickly. But this polynomial, which I plotted here as x squared minus 400x plus 100 pi divided by 3 squared, crosses 0 at 2 points. It crosses 0 right here, and it crosses 0 right there. So I solved for those. Like I said, I solved using, by completing the square, and I also solved it to check my answer just by plugging into the quadratic formula. And the answer that I got are the values for which z is equal to 0 in this equation are z equal to 370.39 and z equal to, so I'll call this, if you like, z1, z2, equal to 29.6. So these are two values of z that solve this equation right here. But remember, we're not looking for z. What we're looking for is x squared, and z is equal to x squared. So we have to take the square root of these two values to find the two values of x. So if this is the value of z, it turns out the value of x that makes that work is 19.24, and you can check that by squaring this and seeing that you get that. And the value of x that makes this work, so this, say, is equal to x, but we found the other value of x that makes this work is x equal to 5.44. So we have two values of x that work. Now, in actuality, what we're getting here is one of these is the value of x, and the other is the value of y. So we could take this to be 5.44, take this to be 19.24, but equivalently, there is another solution to the problem, and that would be if we, for example, look at this triangle that goes something like this. Let me undo that. Draw a straight line. So, for example, if we look at this triangle that goes from here to here and then back down to here like this triangle, boom, 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 also has the same property, and it's just flipping the values. So this now becomes a value of x, this becomes a value of y. So we see we have two triangles to solve the problem. One is the value of x, and the other is the value of y. Now, whenever I do a problem that's as complicated as this, I make sure that it satisfies the conditions, okay, of our problem, that it satisfies the problem as it's given. So what you need to do is compute the area of the triangle with this side, okay, so you remember I said one of these is x and one is y. So you need to compute the triangle that goes 1/2 times 19.24 times 5.44, and you find what that equals. That's the area of the triangle. Then you need to see what the area of the shaded region is. The area of the shaded region, remember, is the area of the semicircle minus the area of the triangle. So the area of the shaded region is going to be pi times 100 times 10 squared divided by 1/2, or 50 pi. That's the area of the semicircle, minus the area of the triangle, which is this. So this is the area of the shaded region. And we needed to find a solution such that the area of the shaded region was twice the area of the triangle. So, in fact, does this, twice the area of the triangle, is 19.24 times 5.44. Now it's up to you. Plug this into your calculator, check it, see what you get.